Alright, welcome. This is the 7.6 Ready, Set, Go homework solution. Alright, we have the ready part. This is talking about rotational symmetry in a regular polygon and with some transformations. Number one, it asks us to give the rotational symmetry for a regular pentagon. Please understand that a pentagon has 5 sides. There is a rotational symmetry formula which is defined by 360 degrees divided by n. That is where n is the number of sides within the polygon. A pentagon is 5 sides, so we set n equals to 5. What I have here is I had the equation 360 divided by 5. That gets me 72 degrees. So the rotational symmetry for a regular polygon is at 72 degrees. All the other ones from it are just multiples of 72. So the first one would be 72 degrees. The second one would be 2 times 72 degrees, which is 144. Right? Then the third one is 3 times 72, which is 216. Then the fourth one would be 72 times 4, which is 288. And the fifth one would be 5 times 72, which is 36. We stop here because you cannot go past 36, as well as this makes sense because it only has 5 sides. So there should be 5 degrees of rotational symmetry. Sorry, 5 different values of rotational symmetry. That's why it's 5 times 72 is the end, and that equals to 30. Number 2, what is the angle of rotational symmetry? Are there for a regular hexagon. Please understand that a hexagon is n equals to 6. Same formula, 360 degrees divided by 6 gets you 60 degrees. So all the rotations are the different multiples of 60. 60, 2 times 60 is 120, 3 times 60 is 180, 4 times 60 is 240, 5 times 6 is 300, and 6 times 60 is 360. Notice the maximum is 6 iterations of, because there are 6 sides to the hexagon. Next, if a regular polygon has an angle of rotational symmetry of 40 degrees, how many sides does the polygon have? Again, to do this, we just do some algebra by setting 360 degrees divided by n equals to 40, because it says the rotational symmetry is 40. Right? Then multiply x to the to get rid of the division. That's how you get 360 degrees equals n times 40. Some of you might see this as cross multiplication. Same thing. I'm trying to get n alone, so I'm going to divide by 40 to both sides. Then 360 divided by 40 is 9. So n equals to 9 angle values for the rotation for the polygon. So it's a nice 9-sided polygon. Okay, I think it's called nonagon. Don't quote me on that. Next one, 4. On each given coordinate grid below, perform the indicated transformation. 4. Reflect point P over point J. Here's point P. Reflect it over point J. There you go. Again, it bends because the line is not straight. This is an equation. Okay, and our point P is right there. Next, rotate point P 90 degrees clockwise. So what I did here is I drew the right triangle for the first P. Notice that it goes down 4, which is vertical, then 4, which is horizontal. Rotate it 90 degrees, so I apply the triangle again. Okay, so it goes down here 4, then it goes to the left 4. Notice this right here will form on 90 degrees because these are perpendicular slopes. Okay, right? That makes sense, right? Because right here, the slope here is negative 4 over 4. The perpendicular slope would be positive 4 over 4. There you go. That would be P prime. Next, you're going to use triangle congruency to justify some conjectures. Construct an isosceles triangle that incorporates CD as one of the sides. Construct the circumference around the circle. Right? So what I'm going to do is I'm just going to delete these in order. Okay. And we'll just fast forward. Alright, so the first one is I got an angle using half of the sort of half of the line segment. Right? And then I constructed another circle using the other half of the circle of the line segment of CD. I noticed that there are intersections here between the two circles, so I drew a ray, which is the green ray. From there, I connected the lines from the radius, the ends of that line segment, to that ray, made two connecting line segments to the tip of the ray. That gives me my sides for my equal isosceles triangle, because these two blue lines are going to be the same. Then I surround the isosceles triangle by a circumference of a circle. There you go. Next one, same thing here. I'm going to just delete this in order of how I did it. Then we'll go back for it. I think that would be a better way of doing it. Right, so the first thing I did is I constructed a circle around the line segment CD. Extend the radius again, because it's the same distance from the center to the circumference of the circle. From there, I constructed a other circle using this radius, the blue radius, okay, so the blue radius helps me construct the orange circle. From the orange circle, I can construct another radius that gives me this line. Then I'm going to do the same thing. I'm going to use this blue radius to construct this green circle. From this green circle, I can also get another radius right there. Okay, then from here, I will construct a purple circle that uses the intersection right here to the center of this circle, as well as the intersection from the orange to the purple to connect there. Okay, this would be a hexagon, because if you notice, this is now 1, 2, 3, 4, a six-sided shape. Okay, I know it's kind of not symmetrical, but I tried my best. Okay. Alright, next one. You're going to construct the square. It's kind of, the construction of the square, this one is a little weird, and I don't want to do it by hand, so I'm just going to show you a video. Okay? Right? Hopefully I did not get copyrighted on this. First of all, what you do is, let me just extend it so I don't get copyrighted. Yeah. Okay. So first of all, you extend the line with the compass, then draw a circle or this arc there. Okay, that's the other end of the circle. Those are the arcs. Then what he's going to do now is that same radius. Okay, he extends the radius twice using the diameter. Right. See, now he constructs a bigger circle. Now he's gonna use the line right there to construct another. Right, this is so he can get the perpendicular line. That's what he's doing. Okay, those are your two x's, or from your intersections from the circles. Now he's gonna connect that point up. He's going to create a line going up and a line going down if he wants to. Now he repeats basically the same process. Okay. He connects that radius. Now he constructs a larger circle. Good. He goes to this point, constructs the circle again, or the arc from that circle. Now he can get the other line. Alright, there you go. That's how you construct a circle, a square. Okay? Alright, let's go to the goal part. Find the distance and the slope. For each pair of coordinate points, find the distance and the slope. You have to just use the formula. Okay, this is the slope formula. Okay, y2 minus y1 divided by x2 subtract x1. Alright, this is x1 is negative 2, y1 is 8. Sorry, x1 is negative 2, y1 is 8, x2 is 3, y2 is negative 4. Plug it into the slope formula, equals negative 12 over 5. It equals negative 12 over 5. Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? Keep it in the square root. You get square root of 169. That equals to 13. Okay? You just have to plug it into the equation. Same thing here for 10. x1 is negative 7. y1 is negative 3. x2 is 1. y2 is 5. Plug into the formula. 5 minus negative 3. Bottom 1 minus negative 7. Gets you 8 over 8 equals to 1. Distance formula, same process. Square root of x1 minus x2 squared plus y2 minus y1 squared. Okay, 8 squared plus 8 squared, 64 plus 64, that becomes 124, right? You could put in a decimal of 11.313708. Okay, again, to do the goal part, you just have to use the slope formula and the distance formula. There's nothing about it. Alright, be very careful with the negatives. The way you go around this is just plug it into a calculator. Alright, 11, 12, and 13 and 14 are shown. I'm not going to show all the steps because it's the same procedure. Use the formula, plug it in, use a calculator so you don't make a mistake on the negative and get your answer. Okay, you could leave the distance as either decimal or in terms of the radical. Alright, 11, slope was negative 1 over 4, distance was 2, radical 17. 12, slope was m equals to negative 3 over 4, distance was 10. 13, m slope was negative 2 over 3, distance was 10, square root 13. 14, m equals to negative 12 over 5, distance was d equals to 130. Okay, there you go. I wanted you to make this short because the last video was like 50 minutes. Okay, if you have any questions, please let me know, but those are all your solutions for 7.6.